Welcome. There is nowhere you need to be right now, and nothing left to solve tonight. Let your shoulders sink into whatever is holding you. Let your breath find its own slow rhythm, unforced, unhurried. Tonight we drift toward a red world, and the quiet question of who might one day call it home. You can close your eyes whenever you like. Nothing here requires your attention, only your rest. Mars was once a wetter world than the dust we see today. Billions of years ago, rivers cut long channels across its highlands, and lakes settled into craters that are now bone-dry. Orbiting spacecraft have mapped ancient shorelines and river deltas frozen in stone. Water did not simply vanish. Much of it slipped into the ground or drifted off into space. The planet remembers an ocean it no longer holds. Curiosity, a rover the size of a small car, has been reading Mars like a patient historian. Since 2012, it has rolled across Gale Crater, drilling into rock layers that once sat at the bottom of a lake. Inside those layers, it found the chemical fingerprints of fresh water, calm and mild, not harsh or acidic. For a long stretch of time, this corner of Mars could have gently supported life as we understand it. No fossil has ever been found on Mars. Despite decades of searching, no bone, no shell, no clear trace of anything that once lived has turned up in the red dust. This absence does not close the question. It simply leaves it open. Astrobiology continues turning over rocks and data, patient rather than certain, waiting for a signal too small to shout, but perhaps too real to ignore. Mars lost its global magnetic field long before life, if it ever existed there, had much chance to flourish. Without that invisible shield, the solar wind slowly stripped away much of the planet's atmosphere over hundreds of millions of years. The sky thinned, the air pressure dropped, and the surface grew colder and more exposed. It is one of the quiet turning points that shaped the world Mars became. Olympus Mons rises taller than any mountain on Earth, nearly 3 times the height of Everest. It forms slowly over countless eruptions on a planet with no shifting tectonic plates to spread the heat around. Standing at its base, if anyone ever does, the summit would vanish into a haze too distant to see. Mars builds on a scale that dwarfs almost everything familiar to us. Deep beneath the southern ice cap, radar signals once hinted at something unexpected. In 2018, a team using the Mars Express spacecraft detected a bright reflection consistent with liquid water, kept unfrozen perhaps by salt and pressure far below the frozen surface. Other researchers have questioned the reading, and the debate continues without a final answer. If true, it would mean Mars still keeps a little liquid warmth hidden beneath its cold. Human footprints have never touched Mars, though closer plans grow steadier each year. Space agencies and private companies speak of the 2030s and beyond, of habitats built from local soil, of greenhouses glowing under thin sunlight. No one yet knows exactly when boots will first press into that rust-colored ground, but the intention has settled into something less like a dream and more like a slow, careful plan. A future Martian settlement would likely begin small, a handful of pressurized rooms buried under soil for warmth and shielding. Radiation on the surface is fiercer than on Earth, with no thick atmosphere to soften it. Engineers imagine homes wrapped in Martian regolith, thick enough to dampen the sky's quiet danger. The first civilization there, if it comes, may live mostly underground, looking upward through small, careful windows. Mars keeps its own slow clock, a day just slightly longer than ours, a year that stretches to nearly 2 Earth years. Anyone living there would feel seasons drag on, an autumn lasting months longer than any they once knew. The sun would appear smaller, paler, and sunsets would carry a faint blue glow, opposite of Earth's warm ones. Life there would learn a new, unhurried sense of time. 2 small moons circle Mars, oddly shaped and impossibly close. Phobos and Deimos look more like captured asteroids than proper satellites, lumpy and cratered, tumbling through their orbits. Phobos drifts nearer to Mars with every passing century, a slow spiral that will one day end in its own quiet unraveling. Deimos, farther out, drifts the opposite way, slipping gradually beyond the planet's reach. 2 moons, 2 futures, neither in any hurry. Across the entire globe, Martian dust can rise into storms that swallow the sun. Every few years, fine particles lift into the thin air and spread until the whole planet seems wrapped in a dim orange haze. In 2018, one such storm grew so vast that it ended the working life of the rover Opportunity. Its solar panels starved of light for months. The storms pass eventually, and the sky always clears again, patient as the planet itself. A person's weight on Mars would drop to roughly a third of what it is on Earth. Someone who weighs 150 pounds at home would feel closer to 57 there, light enough to leap higher, fall slower, move with an odd new grace. Long stays in that lighter pull would likely reshape human bones and muscles over generations, softening what gravity on Earth has always demanded of us. Mars would ask the body to become something gentler, suited to itself. Korolev crater holds a sheet of ice that never melts, sealed year-round by its own cold air. Nearly 50 miles wide and tucked in the northern lowlands, the crater traps a pool of frozen air within its bowl, cold enough that the ice inside stays solid through every Martian summer. From above, the pale white sheet looks almost like a frozen lake, resting undisturbed beneath a butterscotch sky. It has likely kept its shape for a very long stretch of time. 95% of the Martian air is carbon dioxide, thin enough that liquid water boils away at ordinary room temperature. The atmosphere carries barely 1/100th of Earth's pressure, a whisper compared to what we breathe. Standing unprotected there, a person's blood itself would begin to boil at body heat, not from cold, but from the thinness of the sky pressing down. It is a fragile kind of air, unable to hold warmth or moisture the way ours does. The northern and southern halves of Mars look almost like 2 different worlds stitched together. The north lies low and smooth, shaped by ancient lava flows and, perhaps, old ocean basins. The south rises rough and cratered, a highland battered by billions of years of impacts. No one has settled why the divide is so sharp, though one long-standing idea points to an enormous asteroid strike early in the planet's history. The seam between the two remains one of Mars's oldest puzzles. Certain meteorites found on Earth trace their origin back to Mars itself. A handful of these rocks, blasted free by ancient impacts and drifting through space for millions of years, eventually fell to our own soil, most famously across the ice fields of Antarctica. Chemists identified their origin by matching trapped gases inside them to the atmosphere measured on Mars. Each fragment is a small, well-traveled messenger carrying a little of that distant world quietly inside it. Right now, sealed tubes of Martian soil sit waiting in the dust, tucked away for a future mission to carry home. The rover Perseverance has been drilling small cores from rock and regolith since 2021, sealing each sample airtight before setting it down at chosen sites. Engineers hope a later mission, still years away, will retrieve them and bring them back to Earth's laboratories. Inside those tubes may rest the clearest answers Mars has ever offered us. Long before telescopes existed, Babylonian astronomers tracked Mars's reddish wander across the night sky. Clay tablets from thousands of years ago record its movements with careful precision, noting its brightness and its strange backward loops among the stars. Ancient Egyptian and Chinese observers likewise gave the planet names tied to fire and blood, drawn to its unmistakable color. The light those early watchers saw is the same red glow we still see tonight, unchanged across all that human history. Engineers and dreamers alike have sketched plans to someday warm Mars's air, thickening its thin sky. Ideas range from releasing trapped carbon dioxide from the poles to placing giant mirrors in orbit to catch more sunlight. Most such proposals remain far beyond current technology, more thought experiment than blueprint. Still, the idea persists quietly in mission papers and late-night conversations, a distant hope that Mars might one day breathe a little easier. For now, it stays a patient kind of dreaming. Vallis Marineris cuts across Mars like a wound that never healed. Stretching nearly 4,000 kilometers, this canyon system would span a continent if placed upon our own ground. Its walls plunge several kilometers deep, deeper than any canyon known at home. Geologists suspect it formed as the crust stretched and cracked rather than from flowing water alone. Standing at its rim, a traveler could look toward a horizon lost in haze on either side. Rust gives Mars its unmistakable color. The soil holds fine iron minerals that have oxidized over the ages, much the way an old nail rusts in damp air. Wind lifts this fine powder into the sky, staining even the clouds a faint pink. Beneath the surface, fresher rock often reveals darker, less oxidized tones. The whole world wears its rust like a second skin, ancient and slow to fade. Insight, a lander with a single seismometer, once listened for tremors beneath Mars's crust. Across roughly 2 of its rotations around the Sun, it recorded hundreds of faint quakes rippling through the ground. Most were mild, born from cooling rock rather than shifting plates. Others seem to originate near a region called Cerberus Fossae, hinting at buried faults still settling. The sound of each tremor, translated into audio, resembles a low hum fading into stillness. Beneath its rusty surface, Mars hides salts that no farmer would welcome. Perchlorate compounds laced through the dust are toxic in concentration, capable of disrupting thyroid function in the human body. Any future grower would need to wash or chemically treat the soil before crops could take root. Curiosity found traces of these salts early in its mission, buried in samples drilled from shallow trenches. Their presence complicates dreams of simple gardens beneath a dome, though not the dream itself. Phobos drifts closer to Mars with every passing orbit. This moon spirals inward by a few centimeters each rotation, pulled steadily by the planet's gravity. Over a span far beyond any human lifetime, it will likely be torn apart by that same pull, scattering into a thin ring. Deimos, its companion moon, drifts the opposite way, slipping slowly outward instead. The 2 moons seem bound for very different futures, one crumbling, one wandering free. Daytime skies on Mars glow a dusty butterscotch, while sunsets turn strangely blue. Fine dust suspended in the thin air scatters light in ways opposite to our own sky, letting red wavelengths dominate at noon. Near the horizon at dusk, that same dust bends blue light forward, wrapping the setting sun in a cool halo. Photographs from rovers have captured this reversal again and again, still striking to see. It is as if the planet wears its colors inside out. 3 giant volcanoes rise beside Olympus Mons across the Tharsis Bulge. Arsha, Pavonis, and Ascraeus Mons form a line of shield volcanoes, each large enough to dwarf anything found across our own continents. Together with Olympus Mons, they sit atop a swollen region of crust called the Tharsis Rise, lifted by ancient upwelling rock beneath. Their slopes are broad and shallow, spreading gradually rather than rising in sharp peaks. Standing among them, a traveler might barely register climbing at all. On Devon Island, in the far north of our own planet, researchers have built a station meant to feel like Mars. Cracked, cratered ground and biting cold, their eco-conditions crews might face one day. Similar stations sit in Utah's Red Desert, where volunteers wear suits and follow strict schedules to test how isolation shapes the mind. These trials reveal as much about human nerves and cooperation as about hardware. Every simulated mission adds a little more understanding of what waits ahead. A trip to Mars would expose travelers to radiation far beyond anything felt at home. Without a strong magnetic shield or thick air to filter cosmic rays, a crew moving through open space would absorb doses that add up steadily across the journey. Spacecraft designers study ways to shield sleeping quarters with water tanks or stored supplies, hoping to lessen that exposure. Even after landing, the surface itself offers only thin protection compared to what people are used to. Spinning columns of dust wander across Mars's plains on ordinary afternoons. These dust devils form when sunlight heats the ground faster than the air above it, sending narrow vortices spiraling upward. Rover cameras have caught them crossing the horizon like pale, wandering threads. Occasionally, one has swept across a rover's solar panels, brushing away dust and restoring a little lost power. What might seem a nuisance elsewhere becomes, here, an unexpected favor from the wind. In 1894, an astronomer named Percival Lowell built an observatory in Arizona just to study Mars more closely. Through his lens, he traced faint lines across the surface and became convinced they were canals, built by an advanced civilization moving water across a dying world. His books captured public imagination for decades afterward. Later observations found no such structures, only the trick of a telescope's limits and an eye eager to find patterns. Giovanni Schiaparelli, an Italian astronomer working before Lowell, mapped what he called canali, simply meaning channels in his native tongue. Translators rendered the word as canals, an accidental shift suggesting engineering rather than natural grooves. That mistranslation helped spark the entire idea of a Martian civilization busy building waterways. Language, more than the telescope itself, shaped how an entire generation imagined the Red World. A radio broadcast on Halloween Eve in 1938 told listeners that Martians had landed in New Jersey. Orson Welles adapted H.G. Wells's novel into a drama styled as breaking news, and some listeners tuning in mid-broadcast mistook it for real reports. Newspapers the next morning described panic in the streets, though historians now suspect the reaction was smaller than legend claims. That broadcast remained a lasting symbol of how deeply Mars lived in the human imagination. In 1976, twin landers named Viking reached the Martian surface and sent back the first clear photographs ever taken from its ground. Rust-colored rock and a rolling horizon filled the frames, ordinary compared to earlier fantasies of canals and cities. Scientists studied the images for any sign of movement or structure, finding none. What arrived instead was a portrait of a still, weathered world, honest in its emptiness. A cluster of shadows and craters on a Martian mesa once resembled a human face when captured by an early orbiter in 1976. The image spread widely, feeding speculation about monuments left by a lost culture. Sharper cameras arriving later revealed ordinary erosion, ridges and depressions arranged by chance rather than design. The mind's readiness to see faces, a trait called pareidolia, had simply found fertile ground on Mars. Names scattered across the Martian map borrow heavily from mythology and literature rather than science alone. Regions carry titles like Utopia and Elysium, borrowed from ancient stories of paradise, while craters honor scientists and writers who once dreamed of the world. Even the naming process reflects how tightly imagination and discovery have always been woven together on Mars. Every label on the map carries a trace of some earlier storyteller's wonder. Mars Global Surveyor, circling overhead in the late 1990s, detected faint magnetic stripes frozen into ancient crust near the southern highlands. These bands resembled patterns found on Earth's ocean floors, where spreading rock preserves reversals of a once active field. Their presence suggests Mars may have had plate-like movement in its earliest age, before its magnetic shield faded. The rock itself still remembers a version of Mars far more dynamic than the one we see today. Dark streaks sometimes appear on crater walls and slopes during the warmer Martian season, growing across weeks before fading again. Researchers named them recurring slope lineae and once wondered whether trickling brine might explain their spread. Newer studies lean toward dry flows of grain sliding downhill rather than liquid water. The debate continues, a reminder of how carefully Mars guards its remaining mysteries. Ingenuity, a helicopter no larger than a tissue box, lifted off the Martian surface in 2021 and became the first aircraft to fly on another world. Its blades spun through air far sparser than Earth's, requiring speeds much faster than any helicopter here would need. Engineers watched the modest craft rise, hover, and land safely, again and again, well beyond its original plan of 5 flights. It flew dozens of times before its final flight ended its mission. Web-like patterns called spiders spread across Mars's south pole each spring, formed as buried carbon dioxide ice worms and bursts upward through cracks in the surface. Dark fans of grain shoot through vents before settling into branching channels visible from orbit. The process repeats each polar spring, carving fresh patterns into ancient terrain. Nothing like it occurs naturally on Earth, making these formations uniquely Martian in origin. Mariner 4, a spacecraft launched in the mid-1960s, sent home the first close photographs taken from near Mars. The images showed a pitted, cratered ground, nothing like the tidy waterways earlier astronomers had sketched. Scientific hope for canals faded almost overnight, replaced by a stark, cold picture of a battered globe. It was a modest craft, yet it rewrote how an entire generation imagined that reddish speck in the sky. Mars follows an orbit noticeably more oval than Earth's, swinging closer to the Sun at one point and much farther at another. This stretch in its path creates sharper seasonal extremes, especially in the southern hemisphere, where summer arrives shorter but far hotter. Storms and temperature swings both trace back to this uneven distance. Earth's smoother, rounder orbit spares us from such dramatic contrasts. Mars's climate, in this sense, runs on a less even rhythm than our own. Above Mars's night side, pale sheets of light sometimes shimmer without any pole to anchor them. Missions studying the upper air found these auroras spread broadly, unlike Earth's rings around the magnetic poles. Without a global magnetic shield, charged particles from the sun strike almost anywhere across the atmosphere. The glow stays dim, invisible to the naked eye, detectable only through ultraviolet instruments overhead. Mars wears its auroras differently, a diffuse halo rather than a crown. Sojourner, a rover no larger than a microwave oven, rolled onto Mars's ground in 1997 aboard the Pathfinder mission. It carried simple wheels and modest instruments, yet it marked humanity's first mobile visit to another planet. Engineers steered it with commands that took minutes to arrive, watching its slow crawl across red rubble from millions of miles away. Its short mission opened the door for every rover that followed. Curiosity and perseverance both trace their lineage back to this small pioneer. Opportunity, a rover meant to operate for 90 days, kept working for close to 15 years before falling silent. It crossed more distance across another planet than any vehicle before it, wearing down its wheels along craters and dunes. Engineers back on Earth grew fond of its steady, unglamorous persistence, sending fresh instructions onward year after year. Its longevity turned a short experiment into one of the longest-running explorations in planetary history. Few machines have outlived their assignment so thoroughly. During the year 2018, An enormous storm rose across the entire globe, swallowing opportunity's solar panels in a thick haze. Sunlight all but disappeared for weeks, and the rover's batteries drained past recovery. Its final message, relayed through the thinning haze, has since been read by many as oddly poetic, a last signing off after a long career. Engineers waited months for skies to clear before accepting that contact would not return. Even machines, it seems, can end their stories with a kind of grace. Curiosity's sensors periodically catch whiffs of methane rising from the ground, then watch the gas fade again within days. The spikes appear tied to Mars's seasons, though no one has settled why they come and go so unevenly. Methane on Earth often signals biology, but geologic sources can produce it too. Researchers continue comparing readings from orbit and ground level, hoping the two records will eventually agree. For now, the gas keeps its origin to itself. An English novelist named Herbert George Wells imagined Mars as home to an advanced civilization invading Earth in his 1898 book, War of the Worlds. His towering machines striding across English countryside became one of the most lasting images ever attached to the Red Planet. The story reflected genuine scientific speculation of its time, including Lowell's canal theories, wrapped inside an evocative tale. Generations of readers absorbed the wonder his pages carried, long before real spacecraft ever reached Mars. Fiction and astronomy have rarely been so tightly woven together. Mars's backward loop across the night sky puzzled early astronomers long before telescopes existed, since they assumed every planet traced a tidy circle. This strange motion, called retrograde, defied simple explanation for centuries. Johannes Kepler, working from careful records kept by Tycho Brahe, eventually realized that Mars follows an ellipse rather than a perfect circle. That single insight helped topple the old idea of an Earth-centered cosmos. A red light, wandering oddly overhead, ended up reshaping how humanity understood its place among the stars. Phobos and Deimos, the two small moons orbiting Mars, carry an origin still debated among planetary scientists. Their dark, irregular shapes for a time suggested captured asteroids drawn in by Mars's gravity in the ancient past. Newer models propose something different, a giant impact that scattered debris later gathered into these two bodies. Each theory explains some features well and struggles with others, leaving the question open. Two modest moons, it turns out, hold a surprisingly complicated family history. High above the surface, a spacecraft named Maven watches the last wisps of air escape into space. Solar wind, an unending stream of charged particles from the sun, strips away molecules atom by atom. Billions of years ago, the atmosphere of Mars was thick enough to hold warmth and water. Now only a thin remnant survives, still bleeding outward under the light of an indifferent sun. Maven's readings help explain why a once-breathable sky slowly emptied itself. Jezero crater holds the fan-shaped remains of a river that once poured into a lake. Its delta still curves outward in layered ridges, frozen mid-motion for billions of years. In 2021, a rover called Perseverance touched down inside this crater to search its ancient sediment. Scientists chose the site precisely because deltas on Earth are excellent at preserving traces of past life. Every scoop the rover takes, there is a small conversation with a lake that vanished ages ago. Small round pebbles, nicknamed blueberries, once littered a stretch of open plain near Opportunity's landing site. Rich in iron oxide, they formed slowly as mineral, laden water seeped through porous rock long ago. Each one grew in concentric layers, much like a pearl forming inside a shell. Their presence told scientists that liquid water didn't just pass through the area once, but lingered there for a meaningful stretch of time. A handful of tiny stones ended up rewriting assumptions about the planet's watery past. Narrow channels appear on some crater walls, looking almost freshly carved into the slope. They lengthen slightly with each passing season, growing longer during the warmer months before fading from view. Researchers suspect thin films of briny water, or perhaps flowing carbon dioxide frost, might shape these marks. No one has watched the process happen in real time, so the exact mechanism remains only partly understood. Even now, something on that cold red world seems to be quietly reshaping itself. The name Mars traces back to the Roman god of war, chosen long ago for the planet's blood-red glow in the night sky. Ancient Egyptians called it Her-Desher, meaning the red one, while early Chinese astronomers named it the fire star. Nearly every culture that watched the heavens noticed the same rusty color and gave it a name tied to fire or conflict. The label has outlived the empires that coined it, carried forward through centuries of skywatching. A single color, it seems, left a lasting mark on human language. Soviet engineers launched mission after mission toward Mars during the 1960s and 70s, and most never survived the trip. Rockets failed at launch, probes lost contact mid-flight, and landers crashed before sending a single image home. Engineers joked darkly about a curse hanging over the planet, though the truth was simply how difficult interplanetary travel remained. Each failure still taught something, refining fuel systems and guidance long before later missions succeeded. Persistence, more than luck, eventually carried humanity's machines across that distance. Layers of ice near the poles stacked like pages in a very old book, each one holding a record of a different climate. Dust bands mark dry stretches, while clearer ice marks colder, wetter periods stretching back hundreds of thousands of years. Researchers read these layers much the way glaciologists study ice cores on Earth, matching thickness and color to shifts in the planet's tilt and orbit. Nothing needs to be dug to see them. Orbiting radar can trace the pattern from above, a frozen library, quietly keeping its own long history. A laser mounted on Curiosity's mast can vaporize a speck of rock from several meters away without ever touching it. The instrument, called ChemCam, reads the brief flash of light that follows and separates it into colors, identifying which elements are present. This lets researchers study the chemistry of distant boulders long before the rover ever rolls close enough to sample them directly. It works almost like a tiny chemistry lab riding on a slow-moving vehicle. Rock after rock, the laser quietly builds a chemical map of the terrain it crosses. In 2021, a rover named Zhurong touched down on a broad plain called Utopia Planitia. Built by China's space program, it carried instruments meant to probe the soil and search for buried traces of ancient water. Zhurong's name, drawn from a fire god in old mythology, echoed the same fascination with heat and color that shaped the planet's earliest names. It rolled quietly across open ground for many months, sending data back before eventually falling silent. Another nation, another small machine, adding its own chapter to the long story of exploration. Radio signals between Earth and Mars can take over 20 minutes to arrive, depending on how far apart the two worlds happen to be. That delay makes live control impossible, since a command sent in the moment would reach a rover long after the situation had already changed. Engineers instead write detailed instructions in advance, letting onboard systems handle small decisions on their own once they land. It is a strange kind of trust, sending a machine ahead and waiting patiently for word to travel the distance back. Across that vast gap, patience has become an engineering requirement. Phoenix touched down near the northern ice cap in 2008, built to test whether frozen water lay close beneath the surface. Its cameras caught something remarkable: wisps of snow drifting from thin clouds overhead, vaporizing before they ever reached the soil. Instruments confirmed water ice just beneath a shallow layer of dust, settling a question researchers had asked for decades. The mission lasted only months before Martian winter sealed the lander in darkness. A brief visit, but one that answered a lasting question. Mars Express, a European orbiter launched in 2003, has circled the planet for over 20 years without pause. Its radar has probed beneath dunes and polar ice, while its cameras built detailed maps still used by mission planners today. Beyond its own science, the spacecraft has served as a relay, carrying signals from surface rovers back toward Earth. Few missions to Mars have lasted this long or contributed so widely. Its steady orbit has become almost a quiet backbone for everything that followed. Perseverance carried something no earlier Mars mission had: a microphone. In 2021, it captured the actual sound of wind sweeping across the plains, a thin whistling hiss, unlike anything heard on Earth. Engineers later isolated the click of the rover's own laser and the grind of its wheels crossing loose stone. For the first time, Mars was not only seen but heard, its atmosphere given an audible voice after decades of silent photographs. A new sense added to an old exploration. Aboard Perseverance rode a small experiment named MOXIE, designed to pull oxygen straight from Mars's thin, carbon dioxide-heavy air. In 2021, it succeeded, producing breathable oxygen in tiny amounts, proof that a similar device might one day supply fuel or air for human travelers. The process worked much like a small electrochemical furnace, splitting molecules apart under heat and voltage. It was modest in scale, yet its success mattered enormously for anyone imagining a future outpost. A single canister, quietly rewriting what seems possible. Curiosity's instruments found clay minerals layered through Gale Crater's mudstone, a mineral that forms only where fresh water lingers for extended periods. The chemistry suggested a lake with neutral, drinkable-like water, mild enough that microbial life on Earth would have found it welcoming. Such conditions likely persisted for thousands of years, far longer than a fleeting flood could explain. It remains an open question whether anything ever lived in those waters. Still, the setting itself looked strikingly hospitable. Within samples drilled from that same mudstone, Curiosity detected organic molecules, carbon-based compounds that form the chemical backbone of everything living on Earth. Their presence does not prove life ever existed on Mars, since such molecules can also form through purely chemical processes. What it does show is that the raw ingredients were present, preserved for billions of years inside protected stone. Planetary scientists continue studying whether those molecules hint at something more, or simply chemistry doing what chemistry does. 23 years overhead, an orbiter named Mars Odyssey has outlasted nearly every mission sent to the planet. Launched in 2001, its neutron detector first revealed hydrogen signatures beneath the surface, evidence pointing toward buried ice across wide stretches of terrain. That single discovery reshaped where later landers chose to search. Odyssey still relays data today, an aging but reliable messenger passing signals between distant machines. Few spacecraft have quietly shaped so much exploration from so far away. Deimos, the smaller and farther of Mars's two moons, drifts outward with every slow orbit it completes. Phobos, closer and heavier, spirals inward toward an eventual end, while Deimos edges gradually away, following a path more like Earth's own moon. Neither motion happens quickly enough for a human lifetime to notice. Still, over millions of years, the two companions are steadily drifting apart from one another. Two moons, born together perhaps, now writing very different futures. Wind has carved long ridges known as yardangs across parts of the Martian plains, their shapes stretched and smoothed by air moving in one steady direction for eons. The Medusae Fossae region holds some of the largest examples anywhere in the solar system, rows of stones sculpted like frozen waves. Nothing rushed their formation. Each ridge grew fraction by fraction, dust grain by dust grain. Seen from orbit, the pattern resembles claw marks left across the terrain by an unseen hand. When Mars slips almost directly behind the Sun, radio contact with Earth falls silent for several weeks, a period engineers call solar conjunction. Charged particles from the Sun scramble any signal trying to cross that line, so rovers and orbiters are left to operate mostly on their own. Mission teams prepare detailed instructions beforehand, then simply wait for the alignment to pass. It is a strange kind of trust, letting machines carry on unattended across such distance. Contact always resumes once the two worlds drift clear of the glare. Recurring dust devils leave faint trails across the Martian ground, thin pale streaks that mark where a whirl of air once passed. Orbiting cameras have photographed thousands of these tracks crisscrossing the plains like handwriting nobody meant to leave behind. Each trail fades within months, erased by fresh dust settling over the old path. New ones appear again the following season, tracing fresh loops across the same open ground. The planet seems to sketch and erase its own drawings endlessly. A dark boulder-strewn field near Gale Crater puzzled early rover planners, its jumbled rocks scattered as if flung there by some sudden force. Geologists eventually traced the pattern to an ancient impact, debris thrown outward and left resting where it landed. Curiosity rolled carefully through the area, choosing its path stone by stone. Nothing about the field looked dangerous up close, only patient and worn, softened by ages of wind. What once seemed chaotic revealed itself as simple old debris settling into rest. Frost sometimes forms on Martian rocks during the coldest hours before dawn, a thin white film clinging briefly to stone. Cameras aboard Curiosity have caught it glinting under weak morning light before the thin air lets it vanish. The frost never lingers past sunrise, drawn back into vapor as temperatures climb even slightly. Such fleeting moisture reminds observers that Mars still cycles small amounts of water through its air. Even now, it is a brief, fragile shimmer, gone almost as soon as it appears. Beneath Mars's crust, faint tremors occasionally ripple outward, evidence that the planet is not entirely still. InSight's seismometer recorded over 1,000 of these quakes before its mission ended, most far gentler than anything felt on a restless world like ours. Researchers traced several signals to a region called Cerberus Fossae, a network of fractures thought to still shift occasionally. The planet, long assumed dead inside, turned out to hold faint internal motion after all. Mars, it seems, still stirs a little in its sleep. Placeholder. Narration. Beyond routine tremors, InSight also detected the vibration of an actual meteoroid strike, a small object slamming into the surface far from the lander itself. Scientists matched the seismic signal to a fresh crater, later spotted from orbit, confirming the sound had traveled through solid rock across a great distance. It marked the first time an impact on another world had been heard before it was seen. The crater exposed bright ice hidden just beneath the dust, a small secret uncovered by chance. A single strike, felt and photographed, tying two separate discoveries together. Clouds on Mars form far higher than anything drifting through skies at home, some stretching into thin sheets of water ice near the upper atmosphere. Others, made of frozen carbon dioxide, appear even farther out, drifting at altitudes that would seem impossible for cloud formation elsewhere. Observers have watched these wispy formations catch the last light of a setting sun, glowing faintly before fading into darkness. They rarely bring anything resembling rain. Instead, they simply pass overhead, delicate and silent, dissolving as the cold night deepens. Certain craters on Mars hold gullies that look freshly carved, thin channels cutting down crater walls as though something recently flowed through them. Researchers debate whether these features form from trickling brine, tumbling dry sand, or seasonal frost sliding loose under weak sunlight. No instrument has caught the process happening in real time, only the aftermath recorded between orbital passes. The channels shift slightly year to year, proof that something active still shapes these slopes. Whatever the cause, the surface keeps quietly rearranging itself in ways still not fully explained. A mineral called jarosite, discovered scattered across parts of the Martian surface, forms only in the presence of acidic, oxygen-poor moisture. Its detection told geologists that ancient environments here were not uniformly gentle. Some pools were harsh and corrosive rather than calm and inviting. Such variety suggests the planet once held many different chemical settings side by side, not a single unchanging climate. Some corners may have welcomed life, others may have discouraged it entirely. The old surface, it turns out, was far more varied than its uniform red color first suggests. Perseverance carries a shield made partly of aerogel, one of the lightest solid materials ever engineered, wrapped snugly around its most sensitive instruments. The material insulates against the planet's harsh temperature, swings while weighing almost nothing at all. Engineers chose it because traditional insulation would have added too much mass for the spacecraft to carry across such distance. Under a microscope, aerogel looks almost like frozen smoke, riddled with countless tiny air pockets. That strange feather-like material now quietly guards delicate electronics through freezing Martian nights. Image prompts, macro cross-section illustration of translucent aerogel insulation material inside Perseverance rover housing, frozen smoke texture under soft light. On narration, a gentle rest can be found in noticing the shape of your own breathing, how it rises without asking permission and falls away just as easily. There is no task waiting in that rhythm, nothing to solve or carry forward tonight. Let each breath arrive a little slower than the one before it, without forcing the pace. The body already knows how to rest, the way Mars already knows how to spin quietly through its long orbit. For now, there is only this breath and the next. Several Martian volcanoes hide hollow tubes beneath their slopes, stretching for many kilometers, where ancient lava rivers drained away ages past. Skylights, spots where a tube's roof has collapsed, show up as dark openings in images captured from above. Engineers imagining future shelters see these tubes as natural shields against radiation and sudden temperature swings. A cave floor might stay far steadier than the exposed ground overhead. Such hollow passages could someday cradle the first rooms of a settlement, tucked safely below the dust. Curiosity's metal wheels carry a hidden pattern, tiny pairs of holes cut into their treads that spell out letters in Morse code. Engineers designed the marks to trace distance traveled, each impression pressed into loose ground behind the explorer. Read together. The pattern spells the initials of the laboratory that built the machine. Photographs sent home occasionally caught the trail stretching behind the wheels like handwriting in dust. A private signature left unintentionally for anyone curious enough to notice. At the northern Martian pole, a cap built mostly of ordinary ice endures beneath a seasonal skin of frozen carbon dioxide that comes and goes each year. The southern cap behaves differently, holding a stubborn crust of frozen carbon dioxide that never fully vanishes, hiding ordinary ice below its surface. Researchers spent years working out why the two caps keep such different rhythms. Sunlight, tilt, and elevation each play a part in the imbalance. Two caps, two different habits, each keeping its own record of changing seasons. Merit, twin to Opportunity, became trapped in loose sand, hidden beneath a crust of firmer ground near a spot engineers later named Troy. Wheels spun without traction as the machine sank deeper, unable to free itself despite months of careful maneuvering from controllers far away. Even stuck, the explorer kept gathering data, studying soil chemistry from a spot No wheels could reach otherwise. Eventually contact faded as a Martian winter drained its solar panels beyond recovery. What began as misfortune became one of Spirit's most detailed scientific stops. Opportunity once photographed pieces of its own discarded heat shield scattered across ground not far from where it had touched down. The shield's inner surface gleamed silver against the rust-colored dust, a strange trace of manufactured metal resting where it had fallen. Engineers studied the images to learn how the shield performed during its fiery descent through the Martian atmosphere. It remains one of the few times a spacecraft documented its own leftover hardware resting on foreign ground, a brief farewell left behind before the real exploring began. Along Curiosity's route through Gale Crater lies a field of dark dunes named Bagnold. The first active dunes on another world studied this closely, made of basaltic sand rather than the familiar rust-colored dust. The dunes appear almost black against the surrounding ground. Wind steadily reshapes their ridges, shifting grains a few centimeters at a time between each passing season. Instruments measured grain size and movement, comparing the process directly against dunes found in deserts back home. The dark dunes offered a rare chance to watch Martian winds sculpt ground in real time. Grooves streaking across Phobos' surface may mark early cracks forming as Martian gravity slowly pulls the moon apart. Researchers studying the pattern suspect the moon could eventually break into fragments rather than surviving intact until impact. Some of that debris might spread into a faint ring circling Mars, similar to rings seen around giant worlds farther out. No one yet knows exactly when this process might finish, since estimates stretch across tens of millions of years. A moon's slow ending, written into the very stone it's made of. Patterned ground spreads across parts of the Martian Arctic, cracked into polygon shapes by seasonal freezing and thawing hidden beneath the surface. Similar patterns form in cold tundra regions back home, where buried ice contracts in frigid months and expands again once warmth returns. Seen from above, the cracks link into a lattice stretching across flat plains. Their resemblance to familiar Arctic ground offered early clues that ice lingers just beneath Martian dust. A cold season's fingerprint, pressed into the ground and repeated year after year. Retrieving those buried tubes will require a rocket launch straight from the Martian ground, the first launch ever attempted from another world's surface. Engineers imagine a fetch machine gathering the tubes and loading them into a capsule bound for space. Once released, the capsule would need to be caught by a waiting spacecraft circling above, without any crew present to guide the process by hand. Every step depends on machines coordinating across millions of kilometers with no room for correction. A journey home for a handful of Martian dust and stone, carried by machines alone. Warmth has a way of loosening the body, easing shoulders that have held tension since morning. Let the blanket's weight settle like a hand resting lightly against your chest, asking nothing in return. Somewhere far above, the Martian night holds no such warmth, only stone cooling silently under starlight. Here, in this room, warmth stays close, wrapping around you like a promise kept. Let it carry you further from waking, one unhurried exhale at a time. 1999 closed with a costly lesson for Mars exploration. A spacecraft called Mars Climate Orbiter arrived exactly on schedule, then vanished into the thin air above the planet it meant to study. Investigators later traced the failure to two teams working in different measurement systems, one in metric, one in imperial, never quite matching. The orbiter dipped too close, torn apart by friction. It was never designed to survive. A small mismatch in numbers, carried all the way across space. A second spacecraft, sent that same season, went silent during its final descent, Mars' polar lander carried instruments meant to probe the frozen soil near the southern pole, but no signal ever returned after its approach began. Investigators suspected a false reading from a leg sensor, one that may have shut the engines off moments too early. The lander likely struck the frozen plain far harder than intended. Its resting place has never been confirmed with certainty. Utah's Red Desert holds a station built to rehearse life on another planet without ever leaving this one. Crews live inside a cramped cylindrical habitat, stepping outside only in pressure suits, following routines meant to mirror a real mission. Researchers study how isolation, close quarters, and delayed messages home affect the mind over weeks at a time. A similar dome sits on a volcanic slope in Hawaii, used for the same quiet rehearsal. Earth offers a few corners that feel almost like elsewhere. A soil experiment aboard the Viking landers produced a signal that looked almost like breathing. Called the labeled release test, it added a nutrient broth to a scoop of Martian soil and watched for gas escaping, a possible sign of microbial metabolism. The reading rose sharply at first, exactly as living soil might respond. Yet other instruments found no organic matter to support that reading, and the result has stayed unresolved for decades. A single ambiguous curve argued over ever since. A meteorite called Allen Hills 8401 carried tiny structures that stirred a great deal of debate in 1996. Found frozen in Antarctic ice, the rock had traveled from Mars long before humans studied it under a microscope. Researchers spotted shapes resembling microscopic fossils, chains far smaller than anything visible to the eye. Other scientists argued the shapes could form without life at all, through ordinary mineral growth. The question of what those tiny chains truly are has never fully closed. Mineral veins threading through Gale Crater's rock hold traces of boron, a quiet clue about how the past lake there behaved. Boron tends to concentrate where fractures stay damp for an extended stretch, as liquid seeps slowly through stone rather than passing through quickly. Its presence suggests moisture lingered in those cracks, well after the lake above had dried away. A chemical trace, faint but telling, left behind in stone that has waited patiently ever since. Cracked patterns preserved in ancient mudstone record, a lake that dried, filled again, and dried yet again. Each crack formed as fine sediment lost moisture and shrank, curling at its edges the way clay does when left in open air. Layer after layer shows this cycle repeating. Wet seasons followed by dry ones, stretching across a great many turns of the planet. It reads almost like a diary, written in cracked stone rather than ink. 2 points along Mars's orbit hold a cluster of asteroids trapped by gravity's balance, drifting alongside the planet without ever catching up or falling behind. Called Trojans, these rocky companions share the same path around the Sun, held steady by the combined pull of Mars and its star. A handful have been confirmed so far, quietly circling in step with the planet they accompany. They travel together, never touching, bound by nothing but balance. A chunk of plutonium inside Curiosity's frame supplies steady heat and power, letting it work through storms that would blind a solar rover. Rather than depending on sunlight reaching solar panels, the rover carries its own quiet source of warmth, decaying slowly and predictably across many seasons. This steady supply meant Curiosity kept moving, even as skies darkened during the great storm that silenced Opportunity. Something like a small sun, tucked inside metal, indifferent to weather outside. Missions from newer nations now circle overhead, each adding its own chapter to Mars's long story of visitors. The United Arab Emirates sent Hope, an orbiter built to track weather patterns across every hour of a Martian day. China's Tianwen, one arrived carrying an orbiter, a lander, and a rover, all in one mission. Each new arrival adds its own quiet observation to a shared growing record. The planet keeps gathering company, one careful arrival at a time. Seismic waves traveling through Mars's interior revealed a core far larger and more molten than earlier models expected, InSight scientists reported in 2021. The waves bent and slowed as they crossed that hidden metal heart, tracing its size the way sound reveals a room's shape in darkness. This iron core, likely mixed with lighter elements, stays partly liquid even now. Mars, it turns out, still holds warmth within, however faint. Mars's tilt wanders across hundreds of thousands of years, swaying between roughly 11 and 60 degrees, far more dramatically than Earth's own subtle wobble. Such wide swings would have shifted where ice gathered and where warmth pooled, reshaping the climate again and again. Ice once stored at the poles may have crept toward the equator during these ancient swings, long cycles, written into the tilt of a small world turning through cold space. In October 2014, a comet named Siding Spring swept within a whisker of Mars, close enough that its faint tail brushed the outer atmosphere. Orbiting spacecraft tucked briefly behind Mars's bulk for shelter, wary of comet grit moving at tremendous speed. No collision occurred, and instruments recorded a rare meteor shower lighting the sky above Mars that night. A visitor from the outer solar system passing near enough to touch the air. The rover named Perseverance owes its title to a 13-year-old student named Alexander Mather, whose essay won a nationwide contest in 2020. Thousands of proposals arrived from school children across the country, each offering a word to carry into another world. Mather's entry spoke of human resilience, of pressing forward despite difficulty. That single word now rolls across ancient riverbeds, carried on the side of a machine built to search for old life. Each sample tube riding aboard Perseverance is machined from titanium, chosen for its strength and its refusal to react with the rock it holds. Engineers cleaned every tube to levels far beyond typical laboratory standards, guarding against any trace of Earth's own chemistry slipping in. A sealed tube preserves its contents exactly as collected, untouched by outside air. Whatever future hands eventually open them will see Mars almost exactly as Perseverance first found it. West of the Great Canyon system lies a maze of interlocking valleys called Noctis Labyrinthus, its name meaning labyrinth of night. Fractures crossed and recrossed here as the crust stretched near the rising Tharsis bulge, carving a tangle of ridges and troughs. Morning fog sometimes pools within its lowest channels, clinging until sunlight burns it away. Few landscapes on Mars look quite so deliberately woven. Despite towering higher than any mountain on Earth, Olympus Mons rises so gradually that a climber walking its flank might barely sense the incline. Its average slope measures only a few degrees, spread across hundreds of kilometers of shield volcano. Lava flowed here across long ages without building steep walls. Size on Mars sometimes hides itself in ease, greatness expressed through breadth instead of height. Cerberus Fossae, a set of fractures cutting across Elysium Planitia, appears to be one of the youngest volcanic features on Mars, geologically speaking. InSight recorded many of its faint tremors originating from this very region, hinting at heat still stirring below. Streaks of dark volcanic material spread outward from these cracks, laid down perhaps only a few million years ago. Young by Mars's ancient standards, though still older than any human memory. Each afternoon on Mars, during certain seasons, a pale streak of cloud stretches downwind from Artia Mons, one of the great volcanoes along the Tharsis line. Water ice crystals condense as air rises and cools along the slope, forming a plume that can stretch over kilometers before fading with the evening light. Observers nicknamed it the Artia Mons elongated cloud, watching it return year after year like a seasonal signature. A small weather pattern, faithful and recurring, painted across volcanic heights. Roughly half of all missions aimed at Mars across history have ended before reaching their goals. A pattern some call the Mars curse. Distance, timing, and the demands of entering a thin atmosphere all conspire against easy arrival. Yet each attempt, successful or not, adds understanding for the missions that follow. Failure, in this long story, has often been simply an early chapter rather than an ending. Hellas Basin stretches across the southern half of Mars, one of the largest impact scars anywhere in the solar system. A wandering body struck early in Mars's history, gouging a depression deep enough to swallow mountain ranges. Air pressure rises slightly within its lowest reaches, dense enough that liquid water might briefly survive there under the right conditions. Few craters anywhere carry such scale. Aeolis Mons rises from the floor of Gale Crater, a mound taller than many mountain ranges on Earth, though most people simply call it Mount Sharp. Curiosity has spent years climbing its lower slopes, reading each exposed layer like a page torn from deep time. Older rock sits below, younger rock above, a stack recording how conditions shifted across ages. Every meter gained tells a slightly different chapter. Mars's outer shell moves as a single unbroken piece, unlike Earth's crust, which drifts across many separate plates. No boundary here slides against another. No continent creeps toward its neighbor. Heat still escapes upward, but without plates to carry it sideways, the surface simply holds its shape across enormous stretches of time. Craters from ages past remain largely undisturbed, never folded into new mountains. Perseverance's parachute carried a message hidden in plain sight. Orange and white panels formed a pattern that, decoded, spelled out the phrase, "Dare mighty things," a line borrowed from a speech by Theodore Roosevelt. Engineers had also woven in coordinates for the mission's laboratory back home. Cameras caught the fabric billowing during descent, and sharp-eyed viewers on Earth cracked the code within hours. Medusae Fossae stretches for hundreds of kilometers near the equator, a vast deposit of soft, easily eroded material, unlike anything nearby. Wind has carved it into ridges, yardangs, and hollows over long ages, thinning it slowly from above. Its origin still puzzles researchers, whether ash from ancient eruptions, wind-blown dust, or some combination settled there long ago. Few formations on Mars remain so stubbornly unexplained. Schiaparelli, a lander built by the European Space Agency, descended toward Mars in 2016 carrying instruments meant to study dust and weather. Its parachute released too early, and its thrusters cut off well above the surface. The lander struck the ground hard, ending the mission within minutes of arrival. Data gathered during descent still help later teams refine their own landing systems. Pathfinder reached Mars in 1997, wrapped inside a cluster of airbags rather than legs or thrusters alone. It bounced across the surface more than a dozen times before finally settling upright. Tucked inside rode Sojourner, the small rover that would soon roll free and begin exploring nearby rocks. The whole approach seemed almost playful, yet it worked precisely as engineers had hoped. Tianwen-1, China's first mission to Mars, arrived in orbit during 2021 after a journey of many months. Its orbiter carried cameras and instruments to map the surface from above, while beneath it rode the rover eventually known as Zhurong. Together, they marked a new chapter in Mars exploration, one nation joining a list once dominated by only a few. HiRISE, a camera aboard an orbiter circling high above, can resolve boulders no larger than a dinner table from hundreds of kilometers up. Its images reveal avalanche trails, dune ripples, and the faint tracks left by rovers crawling across the surface below. Scientists on Earth study these frames for hours, searching for shapes too small for any earlier camera to catch. Detail, from such distance, still arrives astonishingly sharp. Sample analysis at Mars, an instrument riding inside Curiosity, works like a small chemistry lab tucked into the rover's body. It heats powdered rock until gases release, then sorts those gases to reveal what elements and compounds hide within. Air samples pass through the same instrument, tracking how the thin atmosphere shifts across seasons. Much of what is known about Mars's chemistry traces back to this single patient device. Radar aboard an orbiter once traced buried channels beneath Arabia Terra, wider than any river valley visible on the crust today. These hidden paths suggest water carved its way underground long after the open rivers had vanished from view. Whatever crossed those depths did so unseen, threading through rock for ages before anyone imagined it there. Some questions about Mars live entirely underground, waiting for radar to whisper their answer. Gale Crater's rim once towered far higher than what remains today, worn down across billions of years by wind alone. Dust, moving grain by grain, can accomplish what floods might do in an instant, only stretched across unthinkable spans of time. Watching such patience unfold reminds us how differently time moves on a world without rain to hurry it along. Mars keeps its own pace, unbothered by centuries. Beneath Curiosity's tires lies a stretch of terrain nicknamed the Sulfate-Bearing Unit, a band of rock unlike anything the rover had crossed before. Its layers hint at a lake that thinned toward the end, leaving behind salty minerals as the last waters withered away. Reading these layers feels a little like reading the final pages of a long, slow story. Each stripe of rock marks another chapter closing. Farix, long grooves called linear ridge networks, crisscross parts of Mars, thought to form where mineral-rich water once seeped through, buried cracks and hardened them from within. Wind later stripped away the softer rock around them, leaving lattices of stone standing on their own like the bones of something once buried. Walking among them, a visitor might feel surrounded by architecture no one built. Nature alone drew these lines. Deimos, small and distant, shows a surface strangely smooth compared to its rougher companion Moon. Dust seems to have settled evenly across its old cratered face, softening edges that might otherwise look sharp. From certain angles it resembles a dim stone drifting through the dark, its light borrowed entirely from the sun. Even a moon can wear its age gently. An instrument named Rimfax, riding beneath a newer rover, sends radar pulses straight down to map what lies hidden below the wheels. Its readings have revealed layered structures far beneath the crust, arranged in patterns that hint at old flows of water or lava stacking gradually over time. No shovel could ever dig deep enough to see what radar reveals in an instant. Mars keeps entire histories tucked just out of reach. Ancient shorelines, faint and broken, trace the edges of what may once have been a vast northern ocean covering nearly a third of the planet. The idea remains debated among planetary geologists, since erosion has blurred so much of the evidence over the ages. Still, the outlines that remain follow curves eerily similar to coastlines found on Earth. A dry world may once have known waves. Curiosity's cameras once captured a shimmering formation resembling a tiny flower no larger than a grain of rice, formed from mineral deposits shaped by long-ago water. Geologists suspect it grew slowly as fluid moved through porous rock, leaving delicate structures behind as it evaporated. Such small discoveries carry outsized wonder, proof that even the tiniest details on Mars hold stories worth pausing for. Grandeur, it turns out, comes in many sizes. Perseverance carries 23 cameras scattered across its body, each tuned to a different purpose, from navigation to color imaging to hazard detection. Together they let the rover see almost every direction at once, a vigilance no single human eye could match. Engineers built such abundance not from excess, but from care, knowing how far away help would always be. Every angle matters when home is millions of kilometers distant. Across the decades, Every image, every measurement, every quiet signal sent home has added one more page to a story still being written. No single mission could have told it alone, and no single mind first imagined how far it would reach. Layer by layer, machine by machine, curiosity has carried itself across the dark toward a red and dusty neighbor. The story continues, unhurried, exactly as it always has. Cliffs, called ice-rich scarps, appear scattered through Mars's mid-latitudes, cut open by erosion to reveal buried water ice in cross-section. Orbiting cameras first spotted these exposed layers, some standing taller than an 8-story building. Unlike the deep polar caps, this ice sits close enough to the surface that future explorers might reach it without heavy drilling. A hidden resource, waiting in plain sight. Curiosity returned to the same layered formation again and again, drilling 7 separate sites across the slopes of Mount Sharp over several years. Each sample revealed slightly different chemistry, letting scientists trace how conditions shifted as the ancient lake environment changed with elevation. The rover became, in effect, a careful reader working through chapters written in stone. Patience turned a mountain into a timeline. Manganese-rich deposits turned up in rocks Curiosity examined, a mineral that on Earth usually needs oxygen-rich water to form. Chemists studying the finding wonder whether Mars's ancient atmosphere once carried more oxygen than anyone expected. The question remains open, resting on a single unusual streak of mineral buried in old lakebed stone. Even simple elements can carry surprising implications. A shallow patch of ground, nicknamed Three Forks, now holds a scattered depot of sample tubes, each one set down deliberately by Perseverance. Many samples exist in duplicate, one carried onward, one left resting in the dust, a safeguard in case any future retrieval attempt runs into trouble. It looks like a quiet cache tucked into an empty plain, unremarkable to the eye, yet carrying pieces of Martian history sealed inside titanium. Ingenuity's flying days ended in 2024, long after its planned 5 test flights. The little helicopter completed more than 70 journeys above the Martian ground before a rotor blade struck the surface during a landing and brought its mission to a close. What began as an experiment meant to prove flight was even possible became a lasting companion to Perseverance's long traverse. Its final flight closed a chapter no one expected to last so long. An instrument called CRISM once mapped colors across Mars invisible to human sight, tuning into wavelengths that reveal mineral fingerprints hidden within the dust. Its readings turned up opal-like silica in several regions, a mineral that forms only where water lingered for a long stretch of time. The discovery suggested some corners of Mars stayed damp far longer than the dry, cratered surface would ever suggest on its own. Wrinkled ground, known as brain terrain, spreads across certain regions of Mars, its surface folded into ridges that resemble the surface of a walnut shell. Ice buried beneath the dust likely expands and contracts with the seasons, buckling the ground above into these strange repeating furrows. Seen from orbit, entire fields stretch in tight, looping patterns, as though the land itself had been carefully pleated. Temperatures on Mars can swing by more than 100 degrees Celsius between midday warmth and pre-dawn cold, all within a single rotation. Engineers building every lander and rover must design instruments able to survive that daily extreme without cracking or freezing solid. It is a rhythm far harsher than anything felt on Earth, repeating without pause, season after season, year after year. Bringing samples home will someday require something never yet attempted, a rocket launching directly from the surface of another planet, carrying its cargo up to meet a waiting spacecraft in orbit. Engineers describe the choreography carefully, step by step, aware that no rehearsal on Mars itself will ever be possible beforehand. Every stage must work correctly the first time, on a world where no one can simply walk over and check. Curiosity's odometer, tallied quietly across more than a decade of driving, has now covered a distance roughly equal to a marathon. No single drive covered much ground, some days advancing only a short stretch, careful and deliberate. Yet added together, those small movements built something larger, a slow crossing of an ancient crater floor few had ever imagined a machine could complete. Distance, it turns out, is often made of patience. Beagle 2, a British lander, dropped toward Mars in the winter of 2003 and then fell silent, its signal never reaching home. For years, its fate stayed unknown, filed quietly among the mission's disappointments. Then a sharp-eyed orbital camera spotted it years later, resting on the ground with its petals only partly opened. It had survived the landing after all, just unable to speak. Sound moves differently through Mars's thin air, arriving quieter and lower than it would on Earth, and fading faster with distance. A microphone riding aboard Perseverance recorded the hush of wind brushing past rock and the click of the rover's own laser striking stone nearby. Scientists studying the recordings noted that higher-pitched tones vanish almost immediately, swallowed by the sparse, carbon dioxide air around them. Rosalind Franklin, a rover named for the chemist who helped reveal the shape of Ane, waits for a launch window still years away. It carries a drill built to reach deeper into Martian ground than any earlier machine, searching layers shielded from radiation above. Engineers hope that buried depth might protect organic traces that harsher, exposed ground could never keep safe for billions of years. Every couple of years, Earth and Mars swing near enough in their orbits to make a launch worthwhile. A brief alignment mission planners call a window. Miss it, and a spacecraft must wait for the next one to come around. That rhythm has shaped nearly every mission ever sent, dictating when rockets rise from Earth and when they finally arrive at their distant waiting neighbor. A small weather station riding on Curiosity's mast records wind, air pressure, and temperature through every Martian day and night without pause. Its sensors have logged storms passing, frosty pre-dawn chills, and the gentle push of breezes too weak to feel on Earth. Across more than a decade, that quiet stream of numbers has built one of the most detailed climate diaries ever kept on another world. A spacecraft not yet built will one day wait in Martian orbit, ready to catch a small canister launched up from the ground below. Engineers describe the meeting as a careful dance between two machines moving through empty space, timed to the second. If it succeeds, that canister will carry pieces of Mars back across millions of kilometers to laboratories here on Earth. 3 clusters of giant dishes scattered across Earth, in California, Spain, and Australia, keep watch around the clock, listening for whispers of radio signal crossing millions of kilometers. As our planet turns, one dish always faces toward Mars, ready to catch whatever a rover or orbiter has to say. Together they form an unbroken chain of listening that never quite falls silent. Inside a white dome on a Hawaiian volcano, crews once lived for close to a year without stepping outside, except in a bulky suit, testing how minds hold up in isolation. Researchers studying high seas wanted to learn how small groups manage boredom, friction, and distance from everything familiar. Their findings now shape plans for the tighter, quieter quarters a real Martian crew might someday share. Muscles and bones weaken during the months a crew would spend drifting toward Mars, drained by weightlessness long before any lighter gravity waits on arrival. Astronauts aboard orbiting stations already exercise for hours daily just to slow that loss. Physiologists still study how much strength the body could keep across such a stretch and how quickly it might return once boots finally touch solid ground. Somewhere ahead, in a future none of us can quite date, children may grow up under that dusty butterscotch sky, never having known Earth's blue at all. Whether they would stand taller in the lighter pull of Martian gravity remains an open question, one no generation has yet been able to answer. For now, that possibility stays exactly what it has always been, a quiet, patient hope, drifting somewhere out past the dark. Water locked inside Mars's polar ice, if it ever melted away completely, holds enough volume to cover the entire planet in a shallow sea several meters deep. Layers of frozen water stack beneath thinner caps of frozen carbon dioxide, hidden from casual view. Planetary scientists estimate the total volume by tracking how gravity and radar respond to the ice below. That much water, sealed away in cold storage, hints at a wetter chapter still locked within Mars's frozen crust. Alongside every sample tube sealed by Perseverance rides a matching witness tube, left permanently empty from the very start of the mission. Its clean interior will later be compared against the filled tubes, proving whether any stray molecule hitched a ride from home. Engineers built this simple check to answer a question no camera could settle. A blank tube, carried across millions of kilometers, exists only to tell the truth about what belongs to Mars and what does not. Each morning, a small team gathered inside a laboratory in California opens the newest weather report from another planet before checking anything closer. Numbers arrive describing wind, pressure, and temperature gathered through the Martian night. Meteorologists compare the figures against years of past readings, watching for patterns that might hint at an approaching storm season. Forecasting a whole planet has become, for them, as ordinary as forecasting rain. Sunlight itself helps thin Mars's air, splitting water molecules high above into fragments light enough to escape into space. Ultraviolet light breaks the bonds holding hydrogen and oxygen together, freeing hydrogen atoms to rise past what little gravity can hold. Instruments circling overhead have measured this slow leak for years, watching hydrogen scatter outward in a faint glow. Across billions of years, that steady loss helped turn a thicker ancient sky into the thin one Mars wears today. Craters scattered across Mars carry names, borrowed from scientists who spent careers studying worlds they would never touch themselves. Astronomers, chemists, and mathematicians from many countries and centuries lend their names to these rounded scars, a lasting form of memorial, written in stone. Some craters honor writers instead, blending imagination with observation. Together, the map of Mars reads like a roll call of human curiosity, spread across a whole other world. Engineers at a private company have sketched an enormous spacecraft meant to ferry more than 100 travelers toward Mars within a single flight. Its design borrows from decades of testing, aiming for a vehicle that can launch, land, and fly again without being discarded. No such journey has yet carried a person past the moon, let alone toward another planet. Whether that vision arrives on schedule remains uncertain, though blueprints keep sharpening year by year. Static charge builds inside Martian dust as it tumbles across the wind, clinging afterward to boots, wheels, and solar panels alike. The thin, dry air lets these tiny charges persist well beyond what a moister climate would allow. Engineers designing future gear study this cling carefully, aware that stubborn dust can dim panels and jam machinery over time. Even something as small as static electricity shapes how any future visitor might live and work there. In laboratories far from Mars, researchers grow lettuce and potatoes inside soil built to imitate its chemistry, checking whether crops might someday take root there. Simulated Martian soil lacks nutrients ordinary farmers depend on, so scientists test additives that might coax life from it. Some trials succeed better than expected, sprouting green leaves under artificial light. These small greenhouse experiments carry a hopeful question, whether Mars might one day feed the people who visit it. Twilight lingers on Mars for nearly an hour after sunset, dust suspended high in the air, scattering the last colors of daylight. That same dust bends light in ways that turn the sky faintly blue near the sun and butterscotch everywhere else. Photographers among the rovers have captured this fading light many times, each frame slightly different depending on how much dust rides the wind. Dusk there stretches out, unhurried, slower than the version we know at home. Every rover, every signal, every small discovery sent home has turned one more question into a fragment of answer. Across decades, steady machines have mapped canyons, sniffed air, and drilled stone, each teaching us something new about a world unlike our own. Mars remains unfinished business, more asked about than answered, more visited than understood. Yet each mission narrows the distance between wondering and knowing, one small photograph at a time. So the story rests here, unfinished, the way most true stories are. A red point in the night sky, tracked by ancient eyes long before anyone knew what it was. A world of canyons and frozen poles, of vanished rivers and rovers still rolling. Whatever Mars once held, or someday holds, it has given us something lasting. A reason to look up, to wonder, to reach. Let that wonder settle now. Like breath easing out, rest well, sleep now, under whatever sky is yours tonight.